trying to inject into global.ethereum. Hello, everybody. You jumped a little bit. How's everyone doing? How's Hack MIT going for everybody? Good. Cool. I'm Nick from the Solana Foundation. I'm on the developer relations team, and I also like to build cool stuff. So out of curiosity, who is familiar with Solana in general? Got one person? Cool. What about blockchain in general? Okay, cool. It'll help gauge how I approach this presentation. So the first thing I'll go through is just a high level, like how Solana works and how blockchain works, and then I'll show a specific example project that shows how easy it is to actually do NFTs specifically is the example we're going to go through, but how to actually mint NFTs on Solana, specifically using QR codes. So if anyone has a Solana wallet installed on their phone, you'll be able to scan the QR code if you're selected to the DevNet, and then you can mint compressed NFTs. And I'm offline, so I can't full screen this, but yeah. So Solana has a couple of technical advantages over other blockchains, namely the fast confirmation times and low transaction fees. So single transaction on Solana can be finalized in about 400 milliseconds and propagated through the entire network, which is it's pretty close to 2,000 distributed systems all around the world. Excuse me. On top of that, it's incredibly low transaction fees. So each transaction on the blockchain, you're paying a fraction of a penny. So it's one of, if not the cheapest blockchain that you can actually get performance applications out of. So a quick overview of how Solana works in general is on Solana it's a proof of stake network. So it means all these distributed systems all around the world are called validators, and they're the servers that are actually validating all the transactions. They're doing various security checks, kind of like timestamp checking of is a transaction recent enough for it to still be valid, and some other things like that. And as these transactions get sent to the network, they go to the leader of the blockchain. So basically the leader is the particular server, wherever it is in the world, that is actually finalizing those particular transactions at that timestamp. And each of these transactions get sent to the leader packs them into a block, and then does all the validation and security checks and whatnot on those transactions, and then it propagates them to the rest of the network. Meanwhile, at the same time, the rest of the validators of the network that are not specifically the leader, they're also doing that exact same validation. They're all confirming through the consensus mechanism and propagating it out through the rest of the network. And then all these transactions, when consensus is reached with a supermajority of votes, then the transactions can get finalized and then saved into the state of the Solana blockchain. Each of these transactions can contain multiple instructions. So think of it like a transaction is what the user will actually send to the blockchain. You can think of it like an API request. And then the instructions within the API request is a specific bit of execution that you're trying to invoke on chain. So that could be you're trying to transfer some value, you're trying to store some data. You can have multiple of these instructions inside of a single transaction, as long as you fit within the parameters of, effectively, if you have enough data storage ability within a single transaction. Like a transaction has to be less than 1,200 something bytes. I don't remember the exact number, but as long as you're within the data size restrictions, it's enforced by the blockchain, then your transactions will go through and they'll process. So on Solana, Solana is basically one massive state machine, so every bit of information on the blockchain is always available because it maintains a single global state, which is not true of all blockchains. Different blockchains have different design approaches, and Solana, we try to maintain that single global state. Well, we don't try, we do maintain the single global state. And all of this is stored in accounts. So accounts, you can kind of think of it like a record in a database, where, like a line item in a database, that every single line item is just storing some data. You can always get that from your API, you can get that data. Every single account effectively has a unique key. You can think of it like a primary key in a database record. those are your actual account addresses. You can think of it like your blockchain address, your wallet address, if you're familiar with some of the blockchain terminology. Specifically on Solana, they're a 256-bit address that is base 58 encoded. And that's the standard on Solana is base 58 encoding. And each of these accounts holds some amount of sol balance, because in order to store data on the blockchain itself, you have to pay what we call rent. It's basically like paying for your data storage ahead of time. Based off of some calculations, it's determined how much you actually have to store. So if you created basically an empty account that's just storing the sol token, you're going to pay for rent on that account. You're going to pay something like 2 pennies, something like that, and that's for the life of the account for forever for that data to exist on the blockchain. With accounts, anyone can credit an account. You can always send tokens. You can send fund to an account, and anyone can read the data because it's just a read access. It's public blockchain, public data. But only the owner of an account can actually debit or deduct information, deduct data from the account. Here's the data structure. We're not going to go into the data structure too specifically since this is only for 30 minutes. But the next thing to understand is programs. So programs on Solana, they're called smart contracts on other blockchains, but it's basically the actual code that you're going to deploy to the blockchain, and that way the runtime of the blockchain, specifically the Solana virtual machine, is what's going to grab this program, this bytecode. It's going to actually run it, process it, and handle whatever execution logic is written into your program. Programs are all stored in accounts, just like everything else, because like I said, everything on Solana is an account. And specifically with programs, it's an account that just has the is executable flag, is Boolean statement is true. So if it's executable, it's a program. Pretty straightforward. And one of the things that makes Solana so fast is that programs, they're all stateless. So because everything's an account, every program just stores the particular bytecode, the execution logic that you're writing to actually whatever it is you're trying to accomplish with your program. And they can't write to themselves. They can only read data from themselves. They can only read their own logic. So they actually reach out to other accounts to read the data that's stored within those accounts. So it enforces the stateless nature of all of these. And the reason is because it makes it so Solana can be so incredibly fast. Solana can process about more than 4,000 transactions per second. And life to date, over about 3.5 years since Solana mainnet was launched, there's over 200 billion transactions have been processed. And that's because each of these accounts, because they're all each of these programs, as they're stateless, the runtime can understand which data is read-only and which data is write-only. So when you go to write data to an account, effectively it write locks that account, so that way no one else on the entirety of the blockchain can write that data. And you effectively have claimed that write lock, and then once your particular program has released that write lock, then someone else can then access it and write lock it. But at the same time, anyone can always read that data. Yeah. Okay, so now we're going to go into who's familiar with JavaScript and Next.js and React? Out of curiosity. Okay. So we're going to go into a super quick demo application. This is all written using Next.js, and which is React, if you didn't know, and JavaScript. So this specific one is. So this specific one, it has a single page, and then it has a single API endpoint. This single page, specifically this application, is going to make it so if you load this application, you can actually scan the QR code that's on it, and you can mint a compressed NFT just by scanning the QR code in your Solana mobile wallet. It has launched. So we'll see if it decides to load since it's trying to use Google font. Within here, we're actually right here. So this is the entire portion that's actually displaying this QR code. Simple reactive using a JSX element, and we're just passing in a reference to this particular Solana Pay library. So Solana Pay is a protocol specification on the Solana blockchain that allows, it gives a specification for interacting with the blockchain using a URI format, generally in a QR code format. So that way people can just, like I said, scan a QR code. There's two primary portions of this protocol specification, is a transfer request and a transaction request. Transfer is just, you have funds, I have funds, I want to send you money. A transaction request is any blockchain transaction. Cool, looks like it has minted. So this is what the application actually looks like. We're just generating a QR code and displaying it on the page that meets this URI specification. And this actually just is the keyword Solana as the URI keyword, and then a URL specifically to, right now this one is actually localhost 3000/API/mint, just because that is the, you can see right here. Might be able to see it, my head might be in the way. So this is the only bit of information that's actually encoded in this. So when a wallet, a Solana wallet that knows how to interpret the Solana Pay specification, you scan the QR code, the wallet sees the Solana URI keyword, and then it basically makes a GET request and a POST request to this API endpoint, and then that API endpoint returns a transaction for the user to sign, and then you can do whatever it is with that transaction you want. In this particular case, excuse me, it just mints a compressed NFT to your wallet, which is handled by this logic here. So this is just the actual mint endpoint. It's going to take in some various bits of helper data, and then it's going to create a compressed NFT. It's going to get all the metadata that is required to display this NFT. Since does everyone know what NFTs are? Does anyone not know what NFTs are? Okay, so an NFT is a non-fungible token. So think of it like a certificate of authenticity. So you think of a famous piece of artwork. Someone has authenticated that piece of artwork. Take I don't know, Salvador Dali. Salvador Dali has a bunch of very famous paintings. There's some number of people in the world that are experts in Salvador Dali. We as a civilization trust these individuals to authenticate that this particular painting is a Salvador Dali. That's what an NFT is. It's a certificate of authenticity that someone, in this case the blockchain itself, has authenticated that this information is true and it's correct. And just with blockchain, you get it in a decentralized fashion. So we're giving in the NFT metadata, which effectively is a URL to whatever asset is going to be displayed. So whether that's an image, video, anything like that. It can be pretty much any type of media format. There's some wallets will support different types of interactive media, like you could have an HTML and JavaScript game as your NFT, and then you can play that directly. So we're passing in that data here, and then we're using this helper function, which returns a standard GET request. So that way, basically, it returns a JSON object. So that way, the wallet that's scanning this NFT, it's conforming to the Solana Pay specification, and that way the wallet knows how to interpret that information and present it to the user. And the other portion, like I said earlier, the Solana Pay is GET request and POST request. So now that we've made the GET request, or the GET response, we can handle the POST response, which builds a single transaction and sends it back to the user using this helper function, which dives into a lot more specific blockchain things that I honestly don't have time to cover during this 30 minutes. But basically, we're creating a bunch of accounts on chain. We're doing a bunch of calculations to derive the public addresses for those accounts, and then we can store our information inside of a Merkle tree, and then we can return that particular transaction to the user, serialize it in the correct format for the protocol specification, and then once the wallet gets it, it can then interpret that POST request. It gets a transaction, allows the user to sign the transaction, and then send it to the blockchain, minting the NFT. Cool. Does anyone have any questions on that so far? Yeah, what's up?
So you said one competitive advantage of Solana was like the fast response times, like 400 milliseconds. Do you know like the average response times of your competitors or anything?
So off the top of my head, it does vary based on the particular blockchain. Ethereum, for example, well, Ethereum mainnet, the actual Ethereum blockchain, is somewhere around 10 seconds, somewhere between 5 to 10 seconds. It kind of varies for them, from my understanding. Some other blockchains vary from probably about 3 seconds to 15 seconds, depending on the blockchain. Bitcoin, for example, is 10 minutes or something like that. It's like an egregious amount of time for any activity. But each of these blockchains, they generally have a different purpose. Like Bitcoin, Bitcoin is a value-only chain. You don't have smart contract programmability of the chain. It's just an exchange of data, exchange of assets specifically, these non-fungible or fungible assets. So they don't have the ability to have this programmable logic. You can't write a program and deploy it and actually be able to interact with the blockchain like that. You're only transferring. You're basically changing pointers to who owns what.
Gotcha. Thank you.
So,
what are like the gas or like other fees associated with minting, say, like a small image on chain?
sure. So on Solana, every single transaction takes every single transaction you have to pay a transaction fee. And on Solana, it's specifically it's a fraction of a penny for every single transaction. It's basically a flat fee. There's like some tweaks that, like if you're building an app, you could change it to be slightly higher than that, but it would be slightly higher by a fraction of a penny. But I saw on other blockchains, like it can vary depending on the blockchain, it can vary from $5 to $500, depending on how those networks are set up, how congested they are. On Solana, it's just flat fee across the board, fraction of a penny. And so that's the transaction fee. The other portion of the fee is, so if you're trying to store additional data, like I mentioned earlier, you're storing data in accounts, you have to pay for that data storage. And there is there's a helper function that's built in within the SDKs that you basically ask the blockchain, you tell it how many bytes of data you want to store, and you ask the blockchain how much does this cost, and they'll return you a value. And as long as you put at least that value inside of your particular account, then the transaction will succeed, and then the data will persist forever on the blockchain. You can always store more, you can always pay more, and there's some technical reasons why some people will. But even so like the largest account on Solana is about 10,000 kilobytes is a single individual account, and to store that, it's like maybe one SOL, which is one Solana token. So depending on market rate, it's like $20 to store this data indefinitely. Yeah, does that answer your question?
Yeah, that's perfect.
Yeah.
If you mint an NFT on Solana, it's like public, right? So let's say like I wanted to put like private information on an NFT. Is there a way to do that with Solana?
There are some ways you can do it. It really depends on a lot of factors. General statement is that if you are every transaction data because you're just sending raw bytes to the blockchain just knows how to interpret those bytes and serialize them and deserialize them. So all of that data is going to be public. Now there's some different techniques generally using like zero knowledge proofs, which is like Merkle trees, hash trees, things like that. So you can actually use cryptography in a different way than blockchains normally use them to store private data. But yeah, if you're trying to store just like generic data, like hopefully not someone's social security number, because that seems like an odd thing to do. But if you want to store like name, address kind of stuff, you could like hash it. You can cryptographically hash it using a two-way hash. That way they can still decrypt it and then access it, read that data. Yeah, that's off the top of my head.
Okay. Yeah. Thanks.
Anyone else have any questions? That's pretty much it.
Awesome. All right. Well, thank you so much.